Now, there's a lot of different neat designs that show great wall designs, but I want the whole house done in this stuff. And this is where the arched A-frame design is wonderful, where it comes up like this. And that curve really increases the strength of the construction. It puts the rafters over here in compression instead of into tension if it was flat. And that really significantly increases the strength. Now, the downside of Styro Aircrete is it will not hold a nail or a screw. This stuff is just too soft to be able to do that. Well, that's a problem when you want to hang sheetrock on the inside, for instance, or trim, or tie in a wall into the building. Or you want to hang some kind of siding on the outside, vinyl or lapboard. Or you want to put metal roofing on this thing. So if you put wood trusses inside the wall, now you've got the best of both worlds. You've got all of the wood framing every 24 inches, and that increases the strength tremendously by itself. You mix the Styro Aircrete in there, it packs in rock hard, and it does great. Now, when you make these trusses, and they look like this, to make these trusses, you either rip a 2x4 in half, and you end up with about 1 5/8 by 1 1/2, so almost square. But you want to use the 1 1/2 thickness between your 2x, and then you can use a 2x4 in the middle of it. You end up with a 6 1/8 inch wall. Or you put a 2x6 and you end up with an 8 1/8, or you put in a 2x8 and you end up with a 10 1/8, and so on, for however thick you want to go. You cut 8-inch blocks and you put them on 24-inch centers. You pop 2 nails in each one, and then you can splice pieces. So you would pop half in like that, half in the other, pop 2 nails here. And that's what I did when I built this experiment wall. This is 2 feet by 8 feet, and I wanted to see how strong that they would be. And I used this size. I ripped 2x4s in half, so that's what's on each side over here, and have a couple of braces this way just to hold it. Now, I wrapped it with a cloth, kind of like a roofing cloth, and put these pieces on the side to see if I could pour this thing and get it flat enough without having to put OSB as my mold. Well, it didn't work. This is bulging way too much, and so if I didn't have the cloth on there and just popped it off, I could shave that flat before I put the fiber mesh on there. But ultimately what I wanted to be able to do is wrap it in cloth. And let's say you don't want a stucco, then you would have you could use house wrap for this. And so once you've poured it, now you got to use the OSB to hold it nice and flat, pour it, and then take the OSB off. And now you've got a nice flat surface with house wrap. And then you could put pieces right here. And now you've got a nailing surface with an air gap to be able to put up lapboard siding, vinyl siding, whatever you want it to. So if you're not going to stucco it, this is going to end up being really strong with the Styro Aircrete embedded in it. And that will allow you not to have to stucco it. So maybe you want to sheetrock the inside and put siding on the outside and put metal roofing on. That's all an option. And so if you're doing a gable roof, now this is 1 inch thick. If you want to rely on some of the strength of the Styro Aircrete in the mix, this will work. If you are trying to get under code, this will not fly. You're going to have to use a minimum of a ripped 2x4 or go with a ripped 2x6. And now you've got a very, very solid piece when you use that on either side, and then use the 2x4s, 6/8, whatever you want to in between, and you can splice these pieces together. Now, I go by all of these dumpsters where they're building all these new houses, and if you catch it right when they have house wrapped the house, the dumpster is loaded with 2x material. And I go by on a Sunday afternoon and end up with a trailer full load of scrap lumber, and this stuff's going to the dump. Spend about 2 hours popping the nails out of it, and I've got all this workable material. That entire wall there is all dumpster material. I spliced a couple of pieces, as you can see, and I mean, you can build an entire house with this. I've done this 3 times, and I come home back with just a huge load of lumber. Now, if you're concerned about dumpster diving and getting permission, then speak to the builders and get permission to come in there and pull all their lumber out of their dumpsters. But these make very, very strong trusses. Now, I did some tension strength on this, just on the side. I don't have any equipment to be able to do compression testing on how strong this is. Eventually, I'll get it set up with a hydraulic cylinder that I can compress this and see how strong these things are. And I compared this against a 2x4 structure, 2x6, and this. I really thought this was going to come in right between the two, but this actually came in a little weaker than the 2x4. I'm going to test this here in just a minute and see how strong it is with the Styro Aircrete inside of it, if it'll handle a little more weight before it bends by 1/2 inch. That's what I was using as my barometer. How much weight would you put on this thing before it dips by 1/2 inch? And this came in close, but it was a little lower than the 2x4, and of course the 2x6 was huge amount of weight that I was able to put on that. Now, when you do an arched A-frame design, this is what it's going to look like, and how large your radius is of your arched A-frame will dictate how thick you can go in the material. This 12-foot radius that I'm going with is going to be a 12 by 20, and so the radius is the width of the building. That is the common way of doing it. Now, you could go with a smaller radius and it'll make your roof height lower, but it'll angle in faster, essentially. So instead, like for instance, I could do a 10-foot radius, and it will curve in quicker, and you'll have a lower ceiling. Or you can go with a larger radius, and it will go way up higher, a much gentler bend. Now, with a 12-foot radius, I tried to bend 1-inch material. I snapped the wood before I could bend it into the arch jig. You draw a line of your arc. Essentially, you need to get a board, like a 1x2, and pop a nail on the one side where you hold it down, and then this is going to be your compass, and you put a pencil on the other side at 12 foot, and you draw your arc on the OSB. And then you want to frame that up, that whole OSB section up, support it underneath, get it up on sawhorses, so you've got a workable flat area, and then you start putting blocks all the way around on that curve, and that begins your jig. There are several videos on this. Google or look on YouTube for arched A-frame greenhouses and arched A-frame boat houses. And now they're putting them on 4-foot centers instead of 2-foot centers, which is what we need for to be able to not nail up siding and to ultimately pass code, if that will pass. But they are doing fine with plastic over the top or tarps that they drape over them for the boat shops. And they show how they make these jigs and bend them. With the jig over here, you could actually go 2 layers on the top, 2 1/2-inch pieces, and that will make it much, much stronger as you nail into this. Now, if you glue these joints, it's even stronger. And so you can get a huge bottle of wood glue, put it in a little paint tray with a tiny roller, and just roll these things and pop them together and nail. But once you pull it out of the jig, it holds the shape. And it doesn't take that long to build these things. Google a Larson truss and wall trusses, and you'll see some interesting designs of double wall 2-bys that they typically will use the inside wall as your support, and then the outside is to expand the wall out where they can fit it with insulation. We're doing sort of like that, and that is similar, but we're wanting to frame this thing where it will give it support. So you can do the Styro Aircrete with conventional buildings, straight walls and roofs, and do the entire thing and have a solid enclosure with this material. You could actually build an insulated concrete form house with an arched A-frame design. So you would build your trusses like this, but this would just be on the inside to brace your insulated concrete forms until you pour the concrete. And so you would build your blocks all the way up, following and leaning it on top of the arch. You'd have to put little wedges in there and insulate it with some kind of, you can either do spray foam or do a mud mix to Portland cement and sand mix to mortar them together. And then you can run rebar through it and bend it every 2 feet. So the grid is you could do a 3-inch pipe, like a PVC pipe thickness through your block. So that's how you'd mold the block on a 1 foot grid. And then you need to run rebar every 2 feet horizontally and vertically. And you would end up, your entire structure would be an insulated concrete form structure. And you can make your blocks 8 inches, 10 inches, 12 inches, however thick you want the insulation to be. But that would practically be a tornado shelter when you get done. It would be incredibly strong with rebar and concrete running through the whole structure. Rural King is where I found the cheapest for the FM 160 Drexel. It runs about $30 a gallon if you buy 4 in a box with shipping. And so it's working out to about 55 cents for a load for 35 gallons of mix when you get done in the wall. The fiber mesh, the cheapest I've found here, is at Home Depot. This is, I think, a 4.5 ounce, the lighter version, but still extremely strong. If you buy this in 4-roll pack, they used to have a 6-roll, it was even cheaper, but I'm not seeing it now. But the 4-roll pack ends up being $46 a roll for 38 inches by 150 feet. And so you got 450 square feet. That works out to about 10 cents a square foot. Not bad for your fiber mesh. If you want to go stronger, then you can step it up to a wire mesh, and it'll be about 16 cents a foot for the cheapest wire mesh that I have been able to find to strengthen your walls. So the benefits of building with a wall truss is that you reduce the thermal bridging tremendously. It's just these blocks that are touching wood all the way through. Secondly, when you pour, it's going to fill all through this and tie it all together, and will make your wall extremely strong when you pour the whole thing. 3, you can wire the wall before you pour it. So you would nail your boxes right here, and then you'd run your wires through the holes. Don't even have to drill holes. And now you've got a nailing surface on the inside and outside for siding and sheetrock. And you can use scrap lumber to rip and make all these trusses and piece them together. And virtually nothing is scrap when you get done. If you end up with enough structural strength by itself with the trusses, however you build, potentially you could go with an even lighter Styro Aircrete mix. And for just pure insulation, all you need is to coat the styrofoam with a little bit of Portland cement, and you could have no problem with it too, but once it's dry, you're not going to have mold. Something about mold: styrofoam is inorganic, and so is Portland cement, and so there is no food for mold. You do not get mold on this stuff. And styrofoam will absorb very little water, and so even if it is soaked, drenched in water, it will still have some very good insulative qualities. This is why they like to use styrofoam underground that is exposed to the dirt, because it will not decompose and will absorb very little water and continue to be a very good insulator, and it doesn't lose its R value over time. And Portland cement, it gets stronger if it is in water. I mean, they pour piers in rivers for bridges underwater, and it just gets stronger and stronger. So Portland cement loves water. So that is very unique. Now, if you've got wood in your wall, it's a different story. And so this is organic material. And so if your wall is soaked all the time, then yes, you're going to end up getting some mold growing around this. I've got wood around these windows, and they're framed all the way to the ground. You could, I didn't want to just cut a hole out and put the window in. I wanted to support it all the way to the ground, because ultimately the roof above it needed that structural strength all the way to the ground with a header around the window. Now, a disclaimer here, I have not built the wall with trusses yet, and I've had some wonderful ideas that when I actually would try to do them, I'd run into some issues. So stay tuned on how that project works. I'm sure there'll be some things as I'm working that I hadn't thought about that I'll have to modify, but it seems like it's going to be straightforward on this. I commented on the roof and all being insulated, and that's where the arched A-frame can come into play. The dome house is also a wonderful structure, but because of the complex curves, it can make it difficult to frame it up, and this is why Aircrete Harry does the airform when he pours his dome houses. A dome house is unique. It is not for everybody. And so I showed my wife Steve's house on Dome Gaia website. And I said, honey, what do you think of this house? She looked at that and she said, I'm not going to live in a dome house. I said, honey, where's your sense of adventure? We'd probably be the only house in Limestone County living in a dome house. I'm not living in a dome house. Honey, a dome house is the most efficient, strongest structure you possibly can build with. It's practically a tornado shelter. You're going to have to find you a new wife if you're going to live in a dome house. I knew what her reaction was going to be, but I wanted to get a rise out of her. It was pretty funny. So how cheap is building with Styro Aircrease? So I'm building this 12 by 20, and so I compared building a Styro Aircrete arch frame structure, fully stuccoed and painted with elastomeric roofing paint inside and regular paint on the outside and inside, and then comparing that with a traditional conventional 2x4 constructed wall, R13 bats, OSB on the outside, house wrap, vinyl siding as low a cost as I could find, eaves vinyl, OSB roof with shingles with a 412 gable roof, and then drywall on the inside and painted. And when we do the comparison, the building materials you need for the Styro Aircrete is Portland cement for the Styro mix, the Drexel foam, fiber mesh for inside wrap and exterior of the walls and roof. You need Portland cement and sand for the stucco coats, and elastomeric roofing paint for the exterior and interior paint on the inside. This came to a cost of $1,013 to purchase all of that. And that is using recycled styrofoam, shredding yourself, and recycled 2x4s. Now, the traditional gable roof design came to $3,618. That is 3.5 times the cost of Styro Aircrete. And you have a far better insulated building, and it's sealed tighter, And even if you chose to buy the wood for the trusses, maybe you don't want to go dumpster diving, it'll only add an additional $240 to the cost of the structure. Now that does not include the windows and doors or the slab or the wiring. Those items are all the same for both comparisons. I just wanted to compare the walls and the roof. So what are the challenges of building with alternative building methods? These alternative building methods are not in the code book. And so you have to have an engineer that stamps your drawings saying here is how you build with this alternative building, and here is why it is going to surpass the minimum standards of the building code. And then the inspectors will have a meeting and they'll determine yay or nay whether you can build with it. And so that can be an issue every time you want to build a building with an alternative product. But then if you want financing, this can be an issue because the finance company wants to be able to appraise your house and they have no comparables of other houses that are similar to yours. And if you default on the house and they're stuck with it, can they sell this alternative house? And so they don't even know what to value it at. So typically you end up having to get financing just on your land and then get creative with loans on your 401k, which you can get up to $50,000 on if you have a 401k, and home equity line on your existing house, things like that, to try to get money to build your house. And the other issue is the insurance, because now the insurance company has to rebuild the house if it blows away. And where are we going to find builders to build with compressed earth brick or hemp or adobe or rammed earth or earth bag or Aircrete or Styro Aircrete? So this is the issue. Now I'm trying to do some homework to see if I can find companies that will give mortgages and do insurance on alternative buildings. If any watchers out there have had experience in this, I sure want to hear from you in the comments that we can share to others on this area. Now, if you use wood trusses, you could potentially get this classified as a regular wood-framed house. Now, they may not like your stucco roof, and so you might have to go with a metal roof in that respect. But now you have stucco siding and wood framing, they know how to work with that. So what is my goal with this channel? If I was 30 and hungry, I would be starting a construction company tomorrow, and I would be building like crazy here in the county, Styro Aircrete houses. But I am 60 and I have a well-established financial advisory business, and this is a passion and a hobby for me. I'm seeing the huge potential for recycling styrofoam. We need to find solutions for all of this plastic. Plastic can be recycled, but it is costing so much to melt it down, to sort through it, clean it, and melt it into pellets, that it's costing more than the brand new virgin material. And this is why all the plastics end up landing up in the landfills. When we use it for this, all we need to do is shred it, and we are ready to go to use this material. My goal for this channel is to give do-it-yourselfers the ability, first of all, to build affordable housing. How many videos have you seen of great building strategies that you think, wow, I want to build my house like that? And then you call and you get serious sticker shock on what it will cost to build with that. Number two, I want it to be an easy method that is easy to work with and doesn't require real expensive equipment. Three, I want it to be a quality structure that will be super insulated and will stand up the test of time. And fourth, to build attractive buildings that you can be proud of. What do you think of my trim around these windows that I recently built molded it out of Styro Aircrete? There's just so many cool things that you can do with this product. Now, if this channel starts making a little bit of money, then I want to pour the majority of that money back into research and testing. I want to know what the compression strength is and go to a lab. Find out the true R value of this, and then work with engineers to get methodologies of how we build these trusses and have them willing to put stamps on. Dome Gaia has recently found an engineering firm that's licensed in all 50 states that has different size dome houses already ready to go with their engineering stamp that you can build. We need something similar to that with Styro Aircrete. And then we need to find financing and insurance to be able to build with this quality material. YouTube is an amazing platform for sharing ideas. It used to be back in the 80s, I'd have to go to the library and look up stuff on microfiche, make copies for 10 cents a copy, and then make a 3-ring binder to come up with information on topics I was researching. Now you just Google and you watch YouTube videos. Already, several of you have built different designs of styrofoam shredders. All of them have improved on my original design. This is what I was hoping for. And I hope you guys share some of your designs because they are pretty cool.